Welcome to Groundwork, a podcast from McClanahan Corporation to talk about key material processing topics from agriculture to mining and material recycling. We'll discuss the best ways to process the raw materials that power the world, because if it's not grown, it's mined. And I'm Adam Orner, and I'm the product manager for sampling systems. I've been with McClanahan since 2001. I've participated in a variety of ways. I've pretty much been involved with sampling in each aspect of a project from the beginning through the end in commissioning and field service. So I'll kick it over to Sam. I'll let him introduce himself in a little better detail.
My name's Sam Crawford. I've been at McClanahan Corporation for, about 14 years now. I have 27 years of sampling experience, held various positions at two different companies. My current title is Application Engineering Specialist. Processing sampling RFQs for our domestic and international salesmen is what I do here.
Today, what we'd like to talk about is sampling in general briefly, and then get into a hot topic, something that we tend to have a lot of conversations with customers about, and that is the idea of what type of sampler to use in particular applications. And that conversation generally comes down to some variation of crossbelt samplers versus falling stream samplers. So in order to maybe just sort of give us a little background, touch base on what is sampling and why we might want to do mechanical sampling. Sampling in general terms is collecting a small amount of material that's supposed to accurately represent some larger amount of material. So, how that's done is important. It's the process of sampling, following the rules of sampling, so to speak. So it's kind of process specific. There's certain criteria that we try and follow, the rules of samplings, as I mentioned. So the process is important. It's not a simple matter of just going out and maybe with a shovel and a bucket and grabbing some material. There's ways to approach it, certain rules to follow. So why you would do that in a mechanical sense, it's basically for several reasons. One can be safety, could be just keeping operators out of dangerous situations or away from moving equipment, that sort of thing. Typically, sampling in a mechanical fashion is going to improve your accuracy and your repeatability with the equipment or with the results of the sampling. So you're eliminating potential issues resulting from human error. You're implementing a proper systematic approach. If you want to take a sample every 2 hours, the machine will do that, as opposed to maybe an operator that doesn't quite get out there and the times that are needed for sample collection. In general, it's more efficient. You can do more things online. It'll save labor. So instead of maybe crushing and splitting samples in the lab, you can introduce that into a mechanical sampling system. And some of that stuff will take place in a more automated fashion. So it could be more efficient, less labor intensive. And that, in general, will work towards lowering your costs, make your operation more efficient, take your quality program to being a little more proactive versus reactive, eliminating hidden costs and just streamlining efficiency in general. So those are some thoughts as far as why you might want to do mechanical sampling. So with that, we'll jump into the idea of crossbelt samplers versus falling stream samplers. So to do that, maybe we would do a quick overview of crossbelt sampler and falling stream sampler. So since I'm talking, I'll just start with crossbelt samplers. Crossbelt sampler is a machine that's going to mount on top of a conveyor structure, belt conveyor, and it's going to have a rotating cutter assembly. So if you imagine a big scoop that's going to rotate 360 degrees, goes around in a circle, comes across the carry surface of that conveyor belt. It's going to scoop an increment or a sample off of that conveyor and deposit it into a sample discharge point. And then from there, it'll be processed further in the rest of the sampling system, or it'll just simply be dropped into a container of some kind for taking it to the lab. Crossbelt samplers can range from very small, you could have something in a 12-inch conveyor, all the way up to something very large, 96 or larger conveyors, standard metric designs. We typically break the crossbelt samplers down into 3 different categories. We have a standard duty. That's going to be something more along the lines of a typical application that you might see out there. That would be uh, common tonnage or common belt speed, given a conveyor size. Our next version would be something that's a little more heavy duty, so we call that the heavy duty design. That's going to be getting into larger materials, maybe some tonnages that are a little bit higher for a particular conveyor size, maybe a little more frequent cycles, that sort of thing. Something that's a little above and beyond a standard application. And then our largest machine design would be we call it extreme duty or XD machine, and that's going to be something that's very high tonnage, high belt speeds, quick cycle times, just larger material, some things that are much more abusive in nature, much more difficult applications, just based off of how much material is on the belt, how fast it's moving, and that sort of thing. So with the crossbelt samplers, it's possible to do a good job of sample collection. You have to do the design features correctly. So you want to do things like incorporate a support and contouring system underneath the conveyor belt to make sure that the conveyor belt stays in the correct orientation and shape of the cutter as the cutter rotates through and collects the sample increment. You make sure that no extra material gets into the sample discharge. So we'll install things like baffles. I have to make sure that the cutter assembly rotates correctly. Of course, we have to make sure that there's enough power there to get through the material flow. So a variety of things to keep in mind in order to make sure that crossbelt design is done correctly. But at the end of the day, if you do the design things correctly, implement the machine correctly, you can do a good job collecting material, even potentially fine material, with a crossbelt sampler. So on the other side of that, we have the falling stream, which I'll let Sam talk about.
All right. Falling stream type samplers collect sample increments from a free falling material stream. We call this a vertical entry type whenever it's located within the vertical chute work where the material flows. There's another type. We locate that close to the conveyor head pulley discharge, where the material is generally flung off of the conveyor head pulley. We plot out that trajectory and locate the cutter at a right angle where it intersects that trajectory. We call that type a tangential entry or a TE type cutter. We have 2 types of drives on the falling stream type samplers. One is a linear and the other would be a rotary type. Generally, the vertical type machines are easily installed into the chute work. The ones located at close to the conveyor discharge pulley are generally a little more intrusive and require a little more work to get installed. Falling stream type samplers are generally more accurate compared to cross belts, but like Adam said, you can just make sure that you do the necessary detail work whenever you're maintaining a cross belt sampler to get similar accuracy. Is one better than the other? Adam's going to touch up on that right now.
Yeah, I would just mention that a lot of times the conversations we have with customers or just other folks involved in sampling tend to center around, is one better than the other? Why is one better than the other? There's sometimes some strongly held beliefs one way or the other, but from our perspective, obviously we offer both types of machines, and our approach to this isn't necessarily that one's better than the other. Each of them has a place. There's sort of applications where one might lend itself better to the other. But in short, there's not necessarily one that's better. It's more how it's applied and is it applied correctly. So in order to maybe discuss that in a little better detail, talking about some specific applications that are sort of representative of some of the things that we see on a regular basis as far as RFQs, something like that would be worth discussing, just to sort of share the thought process so you can sort of get an idea for the things we look at or how we make that determination where we think that one type of sampler is better than the other. for a particular customer or particular application.
Some of the details that we'd be looking for each application are information on the conveyor itself, the discharge area, if it's a falling stream type sampler located in that area, the area around where the sampling system is to be located so we can lay it out and get an idea of what we need to quote, the elevation data for the site, the material temperature, ambient temperature, material information such as top size, nominal size, moisture content, surface moisture, and inherent moisture. If it's to be crushed, we would want to know what your product size requirement would be, or if you're following any particular sampling standards, we can get that from that. If you have any drawings available, pictures available of the site or the area where the system's to be located, that would be great. Other than that, I think that would pretty much give us what we would need to provide a quote.
So with that, we'll get into a few applications that we can talk about just to sort of give you the idea of where our head's at whenever we're trying to decide which type of sampler to use. And sometimes there isn't a right answer. Sometimes it's just comes down to customer preference, or sometimes it just comes down to layout constraints. Can you physically put a falling stream sampler, for example, into a particular area? So each application we treat as unique, so we look at them and we try to put together the best solution for the particular set of circumstances that we're dealing with. So first one we'll talk about as kind of a common one, it would be copper concentrate. We could probably extend that to just some sort of a concentrate in general, but this one we'll talk about is copper concentrate. And as you know, concentrate materials got pretty fine material, so we're talking something down in the millimeter or below 1 millimeter range for particle size. This particular application had a 1200 millimeter conveyor, 1,000 tons an hour, and it was 450 feet a minute. So in this case, looking at this, just seeing that it's copper concentrate with very fine material, we would typically just automatically go for a falling stream sampler in this situation. But it's not necessarily quite that cut and dry. There are other like sampling standards, for example, for concentrates that do permit the use of crossbelt samplers. It also depends a little bit maybe on where the application is. Something like this for copper concentrate that's going to be somewhere in South America, for example, it's very likely that the customers are going to prefer or insist upon a falling stream sampler. But crossbelt samplers are becoming more common in these industries, and they are permitted based off of some of the standards that we talk about. So this one most likely is just going to come down to customer preference. Do they have a strong preference one way or the other? And is it possible to actually install a crossbelt sampler in the area that the samples need to be removed from? So our recommendation here would be a falling stream type of sampler. And this being that it's a 1,000 ton an hour application, most likely is going to require multiple stages of sampling. So if we need multiple stages of sampling, most likely that second stage is also going to be some sort of a falling stream sampler. It would be pretty common for us to do a falling stream primary sampler followed by a second falling stream sampler. Sometimes that falling stream sampler in the secondary stage might be a Wiesen. Other times it just might be a smaller version of some sort of a linear crosscut type sampler. So that's sort of how we would break down that particular application for something like a copper concentrate. So application number 2 is copper ore. Maybe let Sam introduce that one and we can kind of hash through that a little bit.
Yeah, application number 2 is copper ore, 75 millimeter top size, and it has high fines. So we would highly lean towards a falling stream type sampler for that, considering the high fines. The conveyor width is 72 inches. The feed rate is 6,000 ton per hour, and the speed, that's a big thing. That's 5.2 meters a second, which is extremely fast. makes it very difficult to design and install a cross belt sampler that's going to be reliable for that speed. That's moving. We try to maintain a 1.5 times the belt speed with the cutter tip speed, and that's at that belt speed. That's moving for a cutter tip speed. It's very extreme on the duty selection for the drive.
On the higher belt speeds, it's easier to maintain that minimum cutter speed, like Sam mentioned there, if the conveyor is larger, because you have a larger cutter radius to work with to determine your tip speed on the crossbelt sampler. But at that speed, you're getting up to the range where it's maybe doable with a crossbelt, but it's still probably at the point where you probably don't want to. This might fall into the category of you can, but maybe you shouldn't. It's like something you can do, but should you? Is kind of where you're at there.
Yeah, there'll be multiple stages of sampling on the system with likely a jaw crusher. And application number 3A, we'll move on to that. That's a coal loadout application, 3-inch top size coal, 84-inch conveyor, 14,000 ton per hour at 1,050 feet per minute. Again, we would lean towards a falling stream type sampler for this application if possible. Sometimes it will not fit, and we are maybe forced to look towards a cross belt.
This is another one of those applications where it's something you can do with a crossbelt sampler, but it's probably something that you shouldn't do. Like, we would prefer to use a falling stream sampler in this case for sure. But loadout applications, we have plenty of examples where we've used falling stream equipment and crossbelt equipment. So this is kind of another either or, and it's sort of just trying to match the specifics of the application to what we have available, what we think is the best suitable option for reliable long-term operation.
Yeah, depends on location of the system, the layout, constraints, so on and so forth.
Yeah, a lot of times a loadout system like this might be installed right at the end of a system, like prior to, say, a train being loaded. So you have vertical height to work with for falling stream equipment. So you may have, for example, hundreds of feet of elevation within this tower and multiple floors to work with. In that case, it may be something where you can easily install equipment that is falling stream.
A lot of times the customer does not want the system to be located in a big tower. They have to crawl up and down the stairs, and they just don't like that. So sometimes we're forced to use a crossbelt closer to grade.
So we said about application example 3A and 3B. So 3B is kind of more of an example of something that would be a crossbelt sampler more commonly, something that we've used in the past with a crossbelt sampler. And so that would be another loadout type of application, but maybe it's the same 3-inch top size of material, but the conveyor could be usually larger with a loadout. So maybe it's 84 again, just for conversation's sake, and say the tonnage might be a little bit less of 4,000 tons an hour. You could still have a fairly quick belt speed at, say, 850 feet a minute. So that would be the basic application, but we have a number of systems out there that are similar to these specs where we're using crossbelt samplers for the application. The 84-inch conveyor, it's going to help you with that cutter radius that I mentioned previously. So even though the belt speed is relatively fast, you're still going to be able to reach that minimum cutter tip speed that you need. And other than that, it's just a matter of having the machine designed to where it'll contain the material that gets disturbed when the cutter passes through the material flow at that speed, and then also blocking any extraneous material from entering the sample discharge. So those are two sort of both ends of the spectrum for a loadout type application. Something that's maybe the same size belt, but one that's significantly higher in tonnage than the other. Generally, with a very high tonnage type of situation, we're going to lean towards that crossbelt sampler, falling stream type sampler, just because that it, especially in loadout applications where uptime seems to be like a higher priority. Like, not that it's not a high priority anywhere, but in loadouts in particular, you tend to have better overall results, reliability, less maintenance, things like that with the falling stream. And then, of course, the other another example was something that's not quite as difficult. That's something that more lends itself to the cross belt design.
Yeah, I know.
So another area to talk about for the selection of equipment would just be what we'll call aggregates in general. So aggregates could be anything from sand all the way up to some sort of a crushed stone, all the way up to maybe something that's run of mine that's maybe larger in size, maybe 12-inch. So it kind of covers a range of things. It could be anything from something smaller in a conveyor size up to something larger. Typically, I think we probably are within 18 to 72 inch widths on conveyor sizes whenever we're talking about aggregate applications. But any way you look at it, you're generally quoting or implementing crossbelt samplers for aggregate applications. It's just sort of an industry thing, I guess. Not that you couldn't put a falling stream system in. It just tends to be difficult to retrofit in a lot of the aggregate plants that you deal with. And the cost point of the crossbelt samplers is usually a lot more palatable for the aggregate applications. So, you could range something from a couple hundred tons an hour up to a couple thousand tons an hour. Belt speeds are usually reasonable, so you're not typically going to see those really fast belts that we talked about a little bit earlier in the podcast here. So let's kick it over to Sam here. He can introduce our next application for discussion.
The next application is phosphate ore. That's 6-inch in top size on a 72-inch conveyor, 1,900 ton per hour at 600 feet per minute. This we would probably lean towards a cross belt if possible, just due to the material size. It'd probably be a 2-stage system with, again, a crusher, a single stage of crushing. So it'd have a primary sampler to a feeder, to the crusher, to a secondary feeder with a smaller cross belt on it, producing a final secondary sampler.
This is another one where you probably could go either way. Typically, once you start getting into the larger materials like 6-inch, definitely anything larger than that, the machines tend to start getting much larger, larger material, larger cutter, then the machine just sort of grows around that, and it takes up a lot more space. It's a bit more challenging, I guess, to implement with the falling stream machine. So that's another factor in there why we would probably determine that the cross belt might be better. Plus, it's large material. There's no notes here that suggest that there's a lot of fines to deal with and that sort of thing.
Yeah, the falling stream would collect much more material than a cross belt as well, so you'd have more material to process through the system.
And at 1,900 tons an hour, that's not real unreasonable as far as the throughput's concerned. 600 feet a minute on a 72-inch conveyor is not particularly fast. So those are some details that we would also look at and think that lends itself pretty well to installing a crossbelt type sampler. And then last application that we have here that we could talk about. This one is sort of something that's entertaining to talk about a little bit. We generally get to see a lot of different applications and materials, and it's kind of interesting to see try and solve that sampling problem a lot of times. But this one's one that we like to talk about just because it's sort of out at the limit of things that we typically would deal with, and it kind of makes you think a little bit and try and figure out how to do some things differently, or try and be creative about how to process stuff. But this one is for precious metals mining, and this is very large material, run of mine, 20-inch material, which is very, very large for sampling application. Even though that very large material is on a reasonably small conveyor, I think it was 42, maybe 48, but reasonably small for the material size. Tonnage was rather low, and it was also rather low belt speed, but it's very challenging to try and do any sort of sampling and follow the rules of sampling when you get into materials of this size. Like if you're talking about our previous application where we're dealing with 8-inch material or 6-inch material, that's a lot more reasonable. That's usually around the upper end of what we would frequently deal with. So when you're getting into something in the 20-inch range, that's quite a bit more interesting. But in this case, for precious metals, often our first thought would be a falling stream, but it'd be pretty difficult to try and put together or design and implement a machine large enough in a falling stream design to handle something like that. So you don't necessarily have the choice here as far as should we use a falling stream. It's probably just not really feasible to do that. So our approach here would probably be based off of something that's cross-belt in nature. And even in a cross-belt sampler, that's going to be a significantly large machine. With 20-inch material, the rule of thumb would be 3 times the particle size of the material for your cutter width. So, right off there, you're looking at a 5-foot wide cutter, which is quite large compared to most of your sampling applications. And then if you think about how big the machine would be in order to accommodate something that is rotating within it that's 5 foot wide, you start to look at, wow, that's a pretty substantial, heavily built, just difficult, application in a very heavy duty machine to handle that. So something interesting. Even just looking at multiple stages of sampling, because you'd be looking at multiple stages of crushing with material that size, probably 2 to 3, maybe 4 stages of sampling with material that size. So you probably be looking at that cross belt sampler on the primary stage. You could potentially, as you get into smaller particle sizes after you crush, then maybe you start looking at some of the falling stream options that we have. And we could do that, a couple different type designs for falling stream equipment. And most likely we would probably go crossbelt sampler primary and then into falling stream subsequent stages. So kind of an interesting application, probably involve a mix of samplers. And here we're talking a lot about crossbelt versus falling stream, but that doesn't necessarily need to be limited to the primary stage of sampling. Oftentimes, particularly if you have higher tonnages or if you have larger material sizes or both, that would most likely put you into a situation where you're probably going to have multiple stages of sampling. So multiple stages of sampling would prevent a larger amount and larger size, particle size of material from going back to the lab for manual handling. So some of that would be handled or taken care of in a automatic fashion with a mechanical sampling system. So in a mechanical sampling system with multiple stages, often we're looking at kind of a process there where we're sampling, we're crushing, we're sampling again. Crush, sample would be the general way we would handle that. So generally, you start with a larger size and a larger tonnage, you're going to end up with a larger mass at your secondary stage. In order to break that down into an acceptable mass at the secondary stage, you would first have to break down the particle size, just because there's an interrelation there between the amount of material that you typically need to collect and the particle size. So smaller particle size would be smaller mass required. So you break that down a couple times, both in particle size and in mass that you're collecting, and that delivers a smaller particle size, smaller mass amount of sample back to the lab for processing. So those are our applications for discussion purposes as far as our podcast for today is concerned. So got a few conclusions here. Kind of let Sam take it away there.
Okay, so in conclusion, one type of sampler comparing the falling stream and the crossbow is not particularly better than the other. There's so many application-specific details and variables involved with each application that the best solution is just, that's how we select it. We collect all the information, all the data, and pick the best solution for each individual application, whether it's a crossbelt or falling stream, whichever it may be.
In general, McClanahan, we offer pretty wide range of sampling options. Obviously, we've got the falling stream equipment and the crossbelt samplers, several different designs for the crossbelt samplers, as we mentioned, but there's also quite a few different variations of samplers that can be considered falling stream as well. We've got what we call baffle plate type machine, where you've got a physical divider between your process flow and your sample side, and that whole plate slides back and forth to collect a sample. You've got an overhead carriage where you've got the drive that basically sits above and in front of the head pulley and a cutter hangs down, passes through the material flow. Wiesen samplers, there's rotary head-end type samplers. I mean, there's a wide range of falling stream options out there. Yeah, if you're out and about, you'll probably find some homemade designs that would fall in that falling stream category as well. Just pretty common, wide-ranging options there with respect to falling stream equipment. But ultimately, we've got quite a bit of experience with both types of machines, lots of options. We take pride in the fact that we customize our solutions to meet customers' needs. Our basic process would be to have a conversation with a customer or any involved parties. It could be multiple, not necessarily just the end user, but basically try and understand what the application is in good detail, what the goals of each involved party are. The next step, we generally would try to determine if there's a international standard of some sort that they're trying to follow, if there's anything that's industry specific or material specific that we should consider that's maybe just specific to this particular application. If not, or we may just go back and look at just basic sampling theory, try and make some calculations and try and put together an application or process from there. But we always have to consider what are the best practices for material handling in general, and then also what's important for sampling. So once we do that, we can always fall back on a lot of experience that we've had in various areas, and then try and package all those sorts of things into one custom suited or custom application or solution for an application that's suited to what a customer is trying to accomplish. So at the end of the day, customers got a problem, and to look at it like a puzzle, we've got a variety of sampling puzzle pieces that we can use to put together that overall picture, whatever suits the application that we need to do. So if you have anything that's of interest to you, or you got some sampling questions, you can feel free to reach out to either Sam or I. We're happy to talk to you, happy to work through that with you. So on that note, thank you for listening to Groundwork, a McClanahan podcast. Be sure to follow us on social media for updates and more content. See you next time.